Title of the first section today is 3 variable equations with infinite or no solutions. We'll continue to solve systems of equations with 3 variables, but in this case we'll have either infinite or no solutions for the answer. First equation is 4a minus 2b plus 8c equals 30. Second equation is a plus 2b minus 7c equals negative 12. And last equation is 2a minus b plus 4c equals 15. Again, to solve these equations, you want to eliminate one variable first. Looking at the equations, the first and second equations, the b's have the same coefficients. So if we take the first equation and the second equation and add those together, the b's will cancel out. 4a plus a would be 5a. Negative 2b plus 2b would cancel. 8c plus a negative 7c would be 1c or c. And 30 plus a negative 12 would be 18. Once you combine two of the equations to cancel out a variable, in this case b, you want to use the other equation, which is the third equation we have not used, and cancel out that same variable. For example, if we take the third equation, we can multiply by 2. That way we'll have negative 2b, and then we can combine it with either equation to cancel out the b's. So continuing on, 2a times 2 would be 4a. 2 times a negative b would be negative 2b. And 2 times 4c would be 8c. 2 times 15 would be 30. From here we can use either the first or second equation. If we copy down the first equation, 4a minus 2b plus 8c equals 30. The first equation is exactly the same as the equation that we multiplied by 2 by. To combine these, we can subtract, because again negative 2b minus a negative 2b would cancel. But in this case the a's also cancel, the b's cancel, the c's cancel, and the 30's cancel when you subtract them. So we'll be left with 0 equals 0. And if you remember from previous sections, this would be infinite solutions. Infinite solutions again, when all the variables cancel out and you're left with a true statement, 0 equals 0. There are infinite solutions for these equations, which means again the equations would be parallel if you graph them. The sum of 3 numbers is 20. The second number is 4 times the first, and the sum of the first and third is 8. Find the numbers. In this question we can write equations using 3 variables for the 3 numbers, and then we can solve for the 3 variables. The first sentence, the sum of 3 numbers is 20. The sum will be adding 3 numbers together. We can use 3 variables like x plus y plus z, and it would equal the sum, which would be 20. The second number is 4 times the first. The second number, which would be y, is 4 times as big as the first number. So if we take the first number and multiply by 4, which is x, that will equal the second number. And last part, the sum of the first and third numbers. First number is x, third number is z, that sum is 8. So x plus z equals 8. From here, we can combine the equations to solve for one variable. The easiest way to solve this is using substitution. If we know y is equal to 4x, we can replace that 4x in for y. And if we take the third equation and solve for z by subtracting x on both sides, we'll have z is equal to negative x plus 8. Then we can substitute that into the first equation for z. So rewriting the first equation will be x plus, instead of y, we'll substitute in 4x, and instead of z, we'll substitute in negative x plus 8 equals 20. Using substitution, we have a single variable x that we can solve for. X plus 4x would be 5x. 5x minus ax would be 4x. Plus 8 equals 20. Subtracting 8 on both sides. 4x equals 12. And dividing by 4, x is equal to 3. Once we solve for one variable, then we can solve for the others. The second equation was y equals 4 times x. We can replace x with 3, so y would equal 12. And the last equation that we created, z equals negative x plus 8. Z would equal negative x, which would be negative 3, plus 8. So z would equal positive 5. So our three numbers would be 3, 12, and 5.